The question says write IUPAC names of the products obtained by the ozonolysis of the following compounds. These are the 4 compounds given here. We have to carry out ozonolysis, and whatever the products are formed, we have to go for the nomenclature. Always keep in mind there are 2 types of ozonolysis methods are there. First one is reductive ozonolysis and second one is oxidative ozonolysis. Reductive ozonolysis is 1-step reaction and oxidative ozonolysis is 2-step reaction. Okay, see the reagent. If we have reductive ozonolysis, in case if we have reductive ozonolysis, so in case of reductive ozonolysis, the reagent which we use O3 and it is what is Zn, we have H2 is there. Okay, zinc is there, ozone is there. And if we have oxidative ozonolysis, in this case ozone is there and ozone, and we have only water molecule, zinc is not there. Okay, we are going to carry out reductive ozonolysis, 1-step oxidation, and we understand how we carry out oxidation. Keep in mind, you can see if you look at the compound, 2 in double bond, 3 in double bond, 1 in double bond, and 1 in here also double bond is there. These all compounds are related to alkane, means will have double bond. Let's say if I take compound CH3, it is CH double bond, it is CH2 is there. We have to carry out ozonolysis, O3 at Zn, it is H2 is there. So how we complete the chemical reaction? Wherever double bond is there, you break both the double bond and attach oxygen on the both side. Okay, break both the double bonds and attach oxygen both side and complete the reaction, 1-step reaction, because this is what reductive ozonolysis. So we get the product, you know, CH3 CHO. This is one product we got. This is one product and this is another product. So we get this is what CH2O. CH2O can also be written as CHO is there. Okay, so this is what aldehyde, ethanol, and this is what methanol formaldehyde. So that is how we have to complete the reaction. Similar way we are going to complete answer this question. So now first we have pent 2 in is there. First compound pent means 5 carbons are there, 1 2 3 and it is 4 and it is 5 is there. 2 in to the second carbon double bond is attached. Satisfy the valency of carbon CH3, it is H, here we have H, it is H2 and this is what we have H3. This is the compound we have. Carry out ozonolysis, we have it is O3 and it is Zn is there, H2 is there. So look at the double bond, we have double bond here, break both the double bond. So this chain is broken. This 3 carbon removed from here, got segregated, and these 2 carbons also. Attach oxygen, because 2 bonds are we are breaking, so we need to attach oxygen so that it can satisfy the valency of carbon. Okay, so this is one product we got, this is another product. So this is the product of 3 carbon, this is the product of 2 carbon. So one product we got CH3, it is CH2 and we have CHO, and another one is what CH3, it is CHO is there, CHO. These are the aldehyde. Okay, aldehyde of 3 carbon, aldehyde of 2 carbon. If you name it, so 1 2 3 carbon are there, we can say propanol, and in this case 2 carbon are there, we can say we have in this case ethanol. Okay, ethanol. These are the IUPAC name we have. So we have to write IUPAC name also. This is your propanol and this is ethanol. Okay, completed. Move on to the next compound. So we have 3,4-dimethyl hept 3 in is there. So first of all, parent chain, go for the parent chain. Hept means hex hept, 7 carbon are there. So we have 1 2 3 4 5 6 and 7 carbon are there. 3 in 1 2 3 to the third carbon we attach a double bond. Then it says 3,4-dimethyl. Okay, dimethyl, more than 1 methyl group are there. Attached to the third carbon, 1 2 3, third carbon we have methyl, and fourth carbon we have methyl group there, 3 and 4, 1 2 3 4, 3 and 4 dimethyl. This is the compound we have, no problem at all. Okay, so in this case we have Zn, we can mention ozone. First of all, we have ozone, and it is what Zn and it is H2 is there. Okay, so look at the double bond. Here we have the double bond, break it, both the double bonds are broken. So this chain is segregated and this chain is also separated. Attach oxygen on both sides to satisfy the valency of. Okay, so addition of oxygen is also an example of oxidation reaction. Okay, so now you can satisfy the valency of carbon CH3, it is H2, it is also H2, here satisfied already, here also satisfied, it is H2 and we have CH3 is there. Okay, so this is we have, this is one product we got and this is another product is there, this is another product. Okay, let's write it. We got a CH3, CH2, CH2 and C, we can mention CH3 and otherwise we can mention like this also. We have CH3 and it is CH3 and double bond we can mention like this. Okay, plus it will be helpful in naming it. We have CH3, CH2, up to here I reached, and then C to this oxygen is attached. Oxygen will always form double bond and then we have CH3 is there. Okay, so you can see oxygen is not at the end, it is given in the middle, so it is a ketone. Okay, do the numbering. 1 2 3 4 5 is there, so we can mention 5 carbon pent 2 on. Okay, because this is ketone is there, so we can mention pent 2 on. We have pent and it is 2 on. Okay, in this case also 1 2 3 4, you cannot do the numbering from this side because we have to allocate minimum number to the carbonyl group. So in this case we can mention but and it is 2 on is there, but 2 on. So this is the nomenclature of these products. Okay, second is done. Move on to the third one. It says 2 ethyl but 1 in. So this is the parent chain we have, it is the parent chain. So but 1 in is there, 1 2 3 and it is 4. 1 in, so means at the end a double bond is present. 2 ethyl, so 1 2 to the second carbon ethyl group means 2 carbons are attached. No problem. Carry out ozonolysis, O3 reductive ozonolysis we are carrying out, H2O. So look at the double bond, satisfy the valency of carbon by attaching hydrogen H3, this is H2 and this is H2, it is H3 and here we have it is H2 is there. Okay, break this double bond, attach oxygen, here also attach oxygen. Write this product, this is one product we got, this is one product, this is another product is there. So we got the product, this is CH3, it is CH2 and C double bond we can mention CH2, it is CH3 is there, and in the bottom we are getting this is CH2O is there. This can also be written as HCHO, generally which we write as a formaldehyde, we can name it as a IUPAC name methanol because it has only one carbon, meth. This is aldehyde, this is ketone. So in this case this is symmetrical ketone, 1 2 3 4 5. In symmetrical ketone we can do the numbering from either side. To the third carbon you can see oxygen is attached, so we can mention pent 3 on. So name of this compound will be pent and it is 3 and it is on is there. Very interesting. Okay, completed. We have a last compound. Move on to the last one. We have one phenyl but, 1 in is there, parent chain. In the last we have but, so we have 1 second third and it is 4 is there. Okay, 1 in is there, let's mention 1 in. Okay, to the first carbon it says 1 phenyl is also there, means to the first carbon itself we have to the first carbon 1 in, to the first carbon itself we have phenyl group is attached, phenyl group, this is what we have. So we have to do the numbering from here, it is 1, it is 2, it is 3 and it is 4, and this is the branching we have. So 1 phenyl and but 1 in is there, 1 phenyl but 1 in, this is the compound we have. Carry out ozonolysis, we have O3 and it is Z and it is H2 is there. Keep in mind benzene ring is having double bond, you cannot break these double bonds because it is having aromatic character. By aromatic character a conjugated system, it is highly stabilized. Okay, so do not disturb this benzene ring, you focus on this parent chain. So double bond is present, satisfy the valency, it is H3, it is H2, here we have H and it is also H is there. Break this double bond, attach oxygen this side. Okay, so we got the product CH3 CH2 and it is CH2. No, sorry, we have CHO is there, CHO. Okay, and then we have benzene ring, and to this CH, and we attach oxygen is there. This is aldehyde, aliphatic aldehyde, and this is aromatic aldehyde. So if you name it, this is what 3 carbon are there, so we can mention propanol, and in this case we can name it benzaldehyde. Common name on carbon CHO is attached to the benzene ring, we say benzaldehyde. If you like this video, please share and subscribe to the channel.